welcome to the conference. We want to thank all our sponsors too. We couldn't do this without them. They've been fantastic to work with. This is SaltStack. Oh yeah, for network and edge device management. So what we're going to talk about today. Aha, yay. Well, first, we need feedback. I think probably you've already heard from some people that that a conference like this takes a long time, a lot of effort to put on. This conference actually has been in development for over a year. So we really want feedback. We want this to be someplace where you'll come back to year after year to learn new stuff. And we can't do that unless we hear from you. So that's how you give feedback if you're going to use the web. There's feedback in the app as well. And I'm always trying to become a better speaker. I don't speak very much, usually a couple of times a year, but I would like to improve, so I appreciate your comments. Also, the code for what we're going to talk about today is in that GitHub repository. There's a couple of different subdirectories in there, one of which is the presentation I just gave, which is a different topic, and then there's a directory in there labeled after the name of this presentation. So feel free to look in there and clone that, mess around with it. We're going to start with a little history lesson based on the pre-conference training. No battle plan ever survives contact with the enemy. That was Helmut Karl Bernhard Graf von Moltke, who was a Prussian general and one of the architects of Germany's wars of unification. So like I said before, the content in this presentation is based on the pre-conference training, which had a very large lab component. And at the end of that, I paraphrased his statement, no lab survives the first contact with its students, because it was a real tire fire first time around. So as I give the demos, keep that in mind. I did work out a lot of the quirks, I think, and I'm going to be able to demo 99% of what we wanted to do there. But anyway. All right. So SaltStack for network devices and edge devices. Now this is all centered around the concept of a proxy minion. Does everybody know what that is? Oh, great. I get to teach something. Awesome. So many years, 3 or so years ago, Tom Hatch came to me and said, I want Salt to be able to control a Junos router. And I said, okay, well, we could probably write an execution module to do that. Let me see what I can put together. So for any of you, if any of you use Junos, you know a lot of the products is based on FreeBSD. So I thought, well, maybe we could put a minion on there. That would be kind of handy. Well, Juniper doesn't want that. They don't want third-party code on their devices, and I can understand their standpoint there. So I wrote an execution module to talk to the Junos device, but to run that code, you'd either have to do salt run, or you'd have to spin up a minion and write some states and call it through this minion, which would kind of talk to the device for you, and that just didn't feel very salty to me. I thought there's probably a better way to do this. So I dug deep inside the minion code and realized that we could actually copy some of that code and set it up so that instead of controlling the machine that the minion was running on, instead, we would call out to a bunch of other functions to communicate with an external device that maybe couldn't run a minion, or maybe didn't have enough power to run a minion, or maybe it was a little tiny device and you really just wanted to grab some temperature measurements from it, or something like that. So that's how the Proxy Minion was born. And it actually has worked out pretty well. In the beginning, it was pretty rocky. We had a lot of warts here and there, but now just about everything works fine. There are caveats, and we're going to talk about those today. So in a standard Salt infrastructure, this is what you have, right? You've got Salt Minions connecting to a master. And if you add proxies to it, it just looks like this. It's really no different. You can have multiple proxy minions running on some machine that you designate. You can also continue to run your regular minion there so that you can manage the machine that runs the proxy minions. And they all just connect to the Salt master. And in general, the Salt master doesn't really know or care that the proxy minion is controlling something other than a server, or a Windows machine, or what have you. To the Salt master, it looks just like a minion. So that means grains targeting works. You've got pillar available, and all those neat stuff that Salt provides. So I put that stuff together, we kind of hammered it out so that it would work, and then the next thing we knew, like a whole bunch of community members had jumped in and written all sorts of really neat proxy modules. Some of these I wrote, some other staff members have written. Let's see, Nicole's not here. Nicole and I wrote the ESXi, the original ESXi proxy minion, which lets you manage an ESXi instance on a machine because, you know, that's, I mean, it's Linux underneath, right? But you can't really run a minion on ESXi. So it talks to ESXi through the VMware API. The vSphere module is like that. That's fairly recent. A lot of that work was done by Morgan Stanley because they have a large vSphere footprint and they wanted to be able to control their vSpheres with, you know, just like other nodes. Also Cisco NSO, Marathon, Kronos, Junos, which was the original proxy module and now does not even resemble what I started with. The community has really taken that and run with it. It's very functional now. And Napalm is the module that Mircea Ulinic has been working on. He's the one that won the Contributor of the Year award, if you were at the keynote earlier, and that was because of Napalm. That guy, holy mackerel, he really knocked it out of the park. So if you're not aware, Napalm is a network abstraction library so that you can talk to many different kinds of devices, but you don't have to use, you know, a whole bunch of different libraries. And Cloudflare, I think it's okay for me to say this, Cloudflare actually uses a lot of different hardware. They didn't standardize on just one vendor. They do that because of cost, and I think they also do that so that they don't get locked in and find themselves kind of behind the 8 ball, so which is a wise move. The last one I want to mention is FX2. FX2 is an interface to Dell chassis, to the iDRAC interface on board those, and that was done for a customer because they would, when they buy this customer buys an awful lot of hardware, and so they get pallets of servers, and they got to rack them, and then they have to go into the GUI and configure them, and that got old quick. I saw the original document. They used the procedures document. It's like 15 pages long, has all sorts of screenshots. It takes like an hour or two to configure each server, and there was no way for them to do that in an automated fashion. So we wrote the FX2 module for them, and now all they need to do is provide the IP address to the management interface and write some states and, you know, salt, yada, yada, and just a few minutes later it's done. Saves them literally hundreds of hours configuring that hardware. So that's really exciting. I like seeing that code being used that way. So I want to show you really quick sample proxy minion. I call this the REST sample because you can use proxy minions not just to talk to devices, but you can use them to talk to services as well. So if there's a service out there you need to use, and it would make sense maybe to get this service involved in your orchestration somehow, you can write a proxy minion for it. They're really not that hard to write. We're going to see the code here in a second. So the proxy minion talks to a very small endpoint, and that's the URL for the GitHub repository that has that endpoint in it. If you want to pull that down, it's not inside the regular source tree. It's separate. It's a very small piece of code that uses Python's bottle HTTP library. And it tries to look like a server, because when I wrote it, I wanted to have so people who knew Salt already would have some familiarity with how it was supposed to work. So it presents a fake server to the endpoint. Make sure my battery doesn't go dead here. There we go. Okay, so first, let me start that up. Okay. So here's the endpoint. And we're just going to have it listen on all interfaces on my local Mac here. Oops, oh, it must already be running. I must have left it running earlier. Oh no, I have a Docker container that's taking that port. Go Docker. Any day now. All right. Okay. So we've got that running, and I also present just a regular HTML interface. So SaltStack Proxy Minion. So here's the services. Let me bring that up a little bit. Here's the services that are running on this fake server that are installed. We've got Apache, we have Postgres, we have a Red Bull service, which that's in there because when I first wrote this, I had like 4 Red Bulls, and I didn't sleep for a week. And we got one package, Core Utils version 1.05, whatever that means. And there's a little button down here that says Simulate Outage. We're going to talk about that in a second. So let me go start. I do need Docker for this. So in one window, I'm going to start a Salt master. I'm just going to run it in debug mode, just for the heck of it. And then in another tab, I'm going to run the Salt proxy. And the proxy ID is going to be REST. Okay. So we're all set. So what happens now is, one more window. Can you all read that? Is it too small? Okay, thanks. So I already accepted its key because I was looking at this earlier. And the key is called REST. So let's just target that. REST test.ping. Okay, and it comes back true. So all that does is just say, is this endpoint here and is it responding? But then we can do some other things because it acts like a fake server. We can do service start Apache. Okay, and that comes back, says it's running, and then if we look in the web interface in just a second, there. So now Apache is running. And we can do the same thing with packages. And it accepts any package name. It's not a real package, it's just an example. So we'll install, oh no, let's install Java. And it says it's installed, and we go here and we look, oh look, we have Java. Okay, the world's gonna end. So the last thing I wanna show you, well actually let's look at the config real quick. So you can put configs for proxies in etc Salt Proxy. And this is a little cluttered because I've used it for a bunch of other things. So master localhost, etc Salt Proxy really pretty much takes like 99% of everything a regular minion config will take. Because it's just a minion, right? So but there are a few extra things. If it's going to be a proxy, it needs to be a top level. It needs to have a top level key called proxy, and then it needs a proxy type, okay? And the proxy type is REST sample. So this proxy type corresponds to one more window. Corresponds to. So I have my source tree in here. Salt proxy corresponds to a PI file that's in the proxy directory. So that's right here, REST sample, and we'll look at that code in just a second. And then there can be any configuration you need that will go underneath the proxy key. In this case, this REST sample needs a URL, and that's the address of the endpoint. And then we've also got this beacon here. So I wrote this to demonstrate that proxy minions can work with beacons. They can work with beacons, they can work with engines, they can work with reactors. They're just a minion to the Salt master. And so what I created was a beacon that watches for an outage of some kind, right? You know, the kind of outage that makes sure, nobody carries pagers anymore, but makes your cell phone go off at 2 a.m. The kind of outage that you would want Salt to fix for you so that you can sleep at night. This is a thing. So let's look at this. Actually, let's just look at the source of the beacon real quick. It's really simple. So we got a virtual, got a validate, and then the beacon itself. So what the beacon does is it just calls the endpoint to look to see if there is an outage. And if there is an outage, it calls another endpoint to fix the outage. So again, this is all an example, but it just illustrates the kind of framework or the workflow you'd like to use to make this happen. So we'll go back here to the web, and we'll say, oh no, the web server's down. It's still down. A few more minutes and my cell phone's gonna go off. And then all of a sudden, ching, Salt's beacon picked up that information, captured the event, decided what to do about it, went ahead and fixed it for you, and now your web server's back up and running again. So you could do this with a regular minion, if you're talking to a regular web server, but you can also do it with a proxy. So, let's say you've got an HA configuration with a couple of routers, and it's just really hard to get them to switch over using the vendor supplied stuff, but I've got this execution module, and when I run it, the failover seems to work fine. So let's just watch for that first router to fall over, and we'll have Salt kick the other one into gear. So that kind of thing can work. So that's the REST sample. There's also one based on SSH. If you've got a device that you need to talk to with SSH, we'll talk a little bit more about SSH in a second. Oh, yeah, I can't flip to the next slide if my presentation's not up. Okay, so if we have time, I'll do this one at the end because I'm afraid I may run out. Because it's 12:30, right? I think. That's when I have to be done. I've got some really cool stuff to show you too. Okay, so like any piece of code, we've got some warts attached to proxy minions. The biggest issue, well, there's two big issues right now. The first is that currently, the way proxy minions work is you need one Salt proxy process per controlled device. That's not really as big a deal as it sounds, but it can get kind of onerous if you have lots of devices, because each proxy process takes about 40 megs of RAM. So on a 4 gig box, you probably could only do about 100 of them. And that also will increase depending on what kind of modules you need to load. So I happen to know for the Napalm stuff, you load those modules, and it's about 150 megs per proxy process. That's kind of a lot. We are working on what we're going to call the Delta proxy, because multi-proxy has a number of different meanings that would probably confuse people. So we're going to call it the Delta proxy, and that's going to be an enterprise feature that will be one process for many devices. And that actually is already working in proof of concept. There's some stuff that I still need to fix, like grains don't work yet, and pillar doesn't work yet, but the basic idea actually does work. I already mentioned you can configure proxies through Etsy Salt Proxy. You can also configure them through Pillar. So you can put all those configuration, you keep all your configuration in the one file, or however you set up your Pillar top files. SSH proxies are currently problematic right now because of a bug in Paramiko and standard in, standard out, standard error handling, where if you open the SSH connection and then you fork, the subprocess hangs up as soon as you start trying to, not hangs up, it stops working, it freezes when you start trying to talk through the SSH connection. So Ed Lane, who's not here, and Ken Jordan, who's not here, but I saw them earlier, they say they know how to fix that. That would be fantastic, because I've banged my head on that one for a couple of years now. Okay, so how do you make these things? At a minimum, you need a proxy module, which I just showed you where they are in the source tree. They can go in the source tree in the salt/proxy directory, or they can go in file roots if you want. And that's kind of a chicken and egg problem. If you're going to start up a proxy and it knows what it is, but it doesn't have the module because the module is not on the system, how does it get the module so it can be the proxy? Well, we handle that inside the startup. We do sync that module down to the machine that's running the proxy minion, and it pulls itself up by its bootstraps and runs the init function. So, and inside that file, you need 6 things. You need a virtual, You need a proxy enabled inside the proxy module, which needs to contain, it's a list, which right now it needs to contain the name of the proxy module, and that's kind of a loader hack because we don't want to load the proxy modules. We want to load all of them. And because there's no way to know, it's chicken and egg again. There's no way to know which module to load until you start the proxy. So we need to know which module to load. We don't want to load all of them just to see which one this one is. So that's why that's there. We need a ping. We need a shutdown. We need an init function that sets up your connection or authentication, authorization, or whatever it is you need to make this thing ready to work. And then you need a function called initialize that's just an accessor that returns whether or not the proxy is currently set up. And that's in there for grains, because if you have to bring up a connection to a device to get its grains in the startup process for the Salt proxy, it can't get those grains until everything is initialized. So that's how it knows if everything's initialized. And then there's some optional stuff. You can do grains. You can put the grains function in the proxy module, or you can put them like other custom grains in salt/grains or in serve salt_grains if you want to sync them over. And then there's, of course, execution modules, state modules, beacons, and engines, whatever else you want to write to interface with this thing. So, let's see, one more slide. Oh yeah, and then virtual providers. So I thought this was really cool. I don't know if you think it's cool or not, but Proxy Minions do support virtual providers. So you saw me run that example just a minute ago where I use the same commands that I'd use for a regular minion to start a service or to install a package. Now maybe your minion, maybe Proxy Minions don't have any concept of packages, or maybe they do. You know, I know there are a number of IoT style devices that you can put modules on. It'd be nice to leverage all that code that we wrote for managing, installing and removing packages and listing packages and seeing what needs to be upgraded. Well, you just need to write all the virtual provider glue to make that happen. And then you could say package install or service start on your Proxy Minion. And that's not the only, we have a number of other virtual providers. I just can't remember what they all are right now. So when you write these things, how do you split up the responsibilities? So this is a question I get a lot about it because you have your proxy module, and then you've got your execution modules, and people ask me, well, what should go where? In general, for the proxy module itself, that really should be all of your communication code. Maybe a variable for a persistent connection, maybe your auth and auth stuff, maybe parsing and data munging of some text that comes back from your device when you start it up. That kind of stuff is a good thing to put in the proxy module. In your execution modules, you'd put logical division of work. For example, we're going to see in a minute, we have a proxy module, see if I have time because we're getting close, to talk to Open Weather Map. And so, maybe you have, in one execution module, you got everything for handling personal weather stations. And in another one, you have everything for handling just getting the weather. That's how you want to split that stuff up. And then state modules, you treat them just like other minions. You can base your state modules on what you've written in your execution modules. And there's a lot of stuff in utils also that you can probably leverage so that you don't have to write a whole bunch of extra code. So how does that work? Well, everything that goes in the proxy module should be available in the proxy dunder variable. So it should be in the proxy dunder variable, and the proxy dunder variable should be available everywhere. It really should. The proxy variable should be available wherever you need it. I've written a lot of tests to make sure the proxy variable is available wherever you need it. So we have this thing inside Salt internals called the pack, and that's where we put all the dunder variable references. And every so often, somebody would commit code to the tree that would make the proxy variable disappear. And that's really frustrating. So we've got tests around that now. Hopefully it won't happen again. I'm not really not pointing any fingers. It's just one of those things that happens when you have a gigantic source tree and people are working in it. So you treat dunder proxy just like you treat dunder salt, except everything in dunder proxy is what's in the proxy module. And so you'd call it like that example there, that next to last bullet there, dunder proxy owm.api. And then Salt's loader will fill in all that stuff and do its magic, and you're off to the races. So the last thing I want to talk about before I show you a couple of demos is what I like to call dual purpose execution modules. This is a little hard to wrap your head around until you've worked with proxy minions for a little while. But there definitely are situations where maybe you're going to write some complicated code in an execution module that does something magic with some device. But you don't always want to spin up a proxy minion just to talk to that device. Maybe, like inserting a DNS entry in one of the DNS service providers. It's kind of goofy. You're like, okay, I just brought the server up. I need a DNS entry. I need to talk to, I don't know, Amazon's IP DNS system. But I don't want to start a proxy minion just to do that. I just need this one thing inserted. So what you can do is write a decorator that wraps that function. And the decorator just needs to be smart enough to know when it's called via proxy. And when that happens, you can precede those extra command line arguments from information that comes out of your proxy module, probably through an accessor function. Or if it's called from a regular minion, then you just require those arguments to be passed in. So that's really handy. It means that you don't have to maintain that code twice. You can just wrap it with this decorator. And the decorators often, it's not a generic decorator. You pretty much have to write it for each individual function type that you might want to use. So if you look in the code for ESXi and Napalm, you'll find some good examples in there. We use that a lot in ESXi in particular. Okay. All right, so before I do the demo, questions so far? Kind of fire hose of information. Okay, great. So for the pre-conference training, I wrote three proxy modules. 2 of them talk to OpenWeatherMap. And yeah, we'll talk about this in a second. 2 of them talk to OpenWeatherMap, and 1 of them talks to this. So this is a Node MCU. If you goof around with Arduino style things or you like IoT devices, these are pretty cool. And in a minute, we're gonna talk to that thing. So let me stop this. Stop the Docker container. Whoops, not there yet. Get that out of the way. No, I'm gonna have to go look. All right. Whoa, all the way up to 7. Okay, 147. Okay, so this is a virtual machine in VMware, and it's running Ubuntu 17.10, I think. And so the first proxy, actually, let me show you the code really quick. Oh, not there. Now this code is online if you want to go look at it. So here's the proxy module for OpenWeatherMap. And so at the top here, we actually don't do any grains in here, so you don't really need the grains cache. But we do need this details variable, this dictionary. Here's the proxy enabled that I was talking about. So this has to be there or else the module won't load. And I really need to improve the error message because right now it just says can't find an init or a shutdown function. It's not very useful. That needs to be more user-friendly. So we import this module, PyOWM, that was written by a nice guy who open sourced it. It's on GitHub. And the virtual doesn't need to do anything. It just makes sure that it got imported. So here's the init. We do a quick log debug to say, okay, I need to So you can look in there and say, oh yeah, the init really did get called, and we're going to say it's not initialized yet. We're going to seed the API key from ops, and we're going to set up a PyOWM object that's going to be stored in details. We're also going to get a stations manager. That's for handling personal weather stations. And then we're just going to call the ping function because it'll return true if it's able to talk to OpenWeatherMap. And then we just return true here as long as the initialized got set correctly. So the initialized accessor is really easy. It's just a return details.get. We do support an alive function nowadays, also thanks to Mirsha from Cloudflare. He got after me about this because some of their devices, they technically time out after like, I don't know, 5 minutes if you're not talking to them, but you can't tell that they timed out. So the next time you go to talk to it, it's like, hey, I'm not here anymore. So alive is a function that you need that will get run periodically to either just keep that connection open or close it and reopen it if the device went away for some reason. And that's available to all proxy minions. And so here's a ping. So in the test module, we actually have special support for this. So if you call test.ping, the test module looks and says, oh, is this a proxy? Well, if it is, let's call this ping function instead. And in this case, we just return, there's actually an API call inside the object. Is API online? So we're going to leverage that. And it returns true if everything's OK or false if not. And then that's what causes ping to decide to return true or false. Like I said, every module needs a shutdown. So in this case, it's a no-op because it's just a REST call. So there's no connection to open and close. And then these are two accessor functions that we use that return references to the objects, either the stations manager or the actual OpenWeatherMap object. So let me show you a little demo here. Let me start the Salt Proxy. And we'll do it in debug mode also. And in this demo, I set up a separate isolated directory trees. So it's salt root, OWM, and then you need to give it a proxy ID. Proxy ID equal OWM. Oh, this has to say etc salt. There we go. Okay, lots of logging. But no stack traces, so that's good. Salt OWM test.ping. Oh, I have to do that as root. Okay, so that returns true, and then you saw some logging going on here. I didn't really do any debug logging about or surrounding the connection, but you do see this initializing new async auth, and then the minion return, which tells you, what's getting returned. So that's OpenWeatherMap. We're talking OpenWeatherMap. Let's get the weather. OWM.weather. In where else? Okay. Let's make this bigger so we can read it a little bit better. Wow, it's really hot today. 291 degrees. So that's in Kelvin. I don't know why. Wind from the south, is that right? 9, yeah. At 13, I think this is miles per hour. And then here's, these are all Unix timestamps, so second since epoch. I guess it's cloudy out, I haven't been outside, so I don't know. And we're not talking about the humidity today. So lots of cool information. And then also, you can look in the source code in the GitHub repo, but we also supported personal weather stations, so we can get a list of them, owm.list stations, and I created these. And then the way that OpenWeatherMap works is you can actually send measurements to OpenWeatherMap, and they will aggregate them for you and perform some magic data analysis on them, and you can pull that information back out. You can do a lot of that with the free API. Also, there's a ton of really cool stuff that OpenWeatherMap does, but you have to use their for-pay API. Like you can't get forecasts through this interface. It won't let you. So that's OpenWeatherMap. I did that specifically to show you that, yes, you could actually connect a proxy minion to a real REST endpoint that actually does stuff instead of just the, the toy one that I just showed you. I think we have 5 minutes. Yeah, I think we have 5 minutes. So if I can make this work, I will demo this. Yeah, so really quick, debugging techniques for proxy minions. If you're working on these things and you're trying to figure out what's wrong, and you see the message, proxy module missing a init or shutdown or both, that's code for I can't load the proxy module. And furthermore, I'm not going to tell you why. The first thing you should check is make sure you have a proxy enabled in there. It could be a Python syntax error. In that case, you can actually just run the Python interpreter on the proxy module file, on the Py file. You won't get anything back because it's not going to do anything, but it is going to go through the compile process. And so at least it will tell you if there's syntax errors. And then you can also start Salt Proxy with the -L debug switch. Yeah, it's way too much output. I mean, it's a ton of output. After you stare at it a while, you do kind of filter out the irrelevancies, and it starts to make more sense. Don't be afraid to throw a bunch of log messages in there, or add unique strings to your debug lines to make them easier to find, or surround your debug lines with these character delimiters so they're much easier to see or to grep for. Those are all techniques I've used, and they're effective. And also, you can use a debugger. So Salt has a ton of signal handlers, and that makes debuggers like PDB sometimes hard to use. But the remote ones I've used all seem to work pretty well. I highly recommend PyCharm. I've been using it for years. It's an amazing environment. I'm not really an IDE person. I'm more a command line plus Emacs plus Vim kind of person. But PyCharm's remote debugger is pretty slick. And then there's also PyDev, which is Eclipse-based. And there's WinPDB, which I don't think is developed anymore, and I'm not sure if it works. At one time, it was the only debugger I know of, outside of maybe Wing, that could debug Python multi-threaded code. And then if you're a Visual Studio person, Visual Studio actually has a whole Python module set and a remote debugging server, though I will observe that the initials PTSD are in there. I guess I won't knock the Visual Studio users in the room. Okay, so we did that. Yeah, in Kelvin versus Celsius. That's a funny meme. I had to put it up there. All right, so about this little thing, Node MCU Dev Kit. It's an open source Internet of Things platform. It's based on Espressif's ESP8266. Those are really popular and they're very cool. So it marries a Wi-Fi controller with a Tensilica LX106 core, 32-bit RISC running at 80 megahertz. It's got 4 megs of flash, 64K of instruction RAM, 96K of data RAM, and it's got a whole ton of I/O on it, from GPIO to SPI, I2C, I2S, UARTs. There's an ADC on there. And then the Wi-Fi controller supports 802.11b, G, and N. You can make this thing an access point if you want. I thought it would be fun to set one up and make it behave like the Starbucks access point and see what you could get. But that doesn't work for N. 802.11n only supports being a client. So, oh yeah, and then it runs Lua. And there's a serial to USB bridge on here. The Lua core is not multi-threaded. It takes advantage of callbacks to perform all the asynchronous stuff. It does have a basic file system on board, and you can run code directly from the flash, so that kind of mitigates the small amount of instruction RAM available. And there's just a ton of modules for this thing. HTTP, TLS, WS2314s for blinky LEDs, all sorts of stuff. It's pretty neat. There's an online service you can use to build your own custom firmware, so you can leave stuff out that you don't need. As of the day before yesterday, it wasn't working, but I'm sure that guy's going to get it fixed. It's pretty slick. Okay. Oh yeah, so that's the last slide. Now let me see if I can get this thing to talk to my machine. This has been really problematic and very frustrating. Plug it in, flashy light, and VMware. Yeah, it says it's connected. So we'll use this utility called ESP tool. Let's see if I can get the chip ID. Oh, but not as root. Yes, it's awake. It's alive. All right, so now let me start the other proxy, which is in here. Okay, yep, that looks like it's working. And we move this over here. So let's see if I can ping the device. Oh, let's see. Still have the key? Yes. Yep, okay, so it's there. So when we ping it, we just spit some stuff out the serial port and look for a response. So what I set this up to do is scan for access points. So every 15 seconds it runs a scan, sees what access points are out there. And then as you get new ones, there's a beacon that emits code onto the Salt event bus so that you can do something when you see these new access points. Now the one thing I did find, yeah, it's already happened once. Here in the Salt Palace, there are a whole bunch of access points. A lot of them are hidden, and we actually, on this little device, we end up running out of memory just scanning for them, and then it restarts itself. So I'm not sure if I'm going to be able to get anything out of it that's really useful because it keeps restarting. But if we watch, let's see, I know we're at time, so. If we watch the event bus, we may be able to see a bunch of them swing by before it keels over. So while we're waiting for that, also, I said there's a small file system on here, so I wrote the execution module so that you can actually list the files, node MCU, node MCU.list, and I should list a couple of files. Oh, except I have to do that as root. Oh, and I can't typo it. Salt's not that smart. Yeah, it's kind of hosed. So you can upload files, node MCU, see if I can put them up there, upload. And you can do it actually out of the Salt file system, salt files, init, Lua. Okay, and then I've got one called scan results. So if I list now, if I spell it right anyway. Yeah, so those are the files. So I know it's just like doing an LS, but it's doing it all in here. And we'll try one more time to see if I can scan. Yeah, it's not going to return anything. If I look at the other. Yeah, so these are the startup events. And ideally what would happen is you'd actually see the access points scroll by in the event bus, so you can grab those events and do something with them. But yeah, it says by argument, table or rotatable expected got nil, so we're not quite there with it yet. I think probably if I told it not to pick up all the hidden access points, it would probably work, but we're out of time. So let me answer questions really quick. Any questions about this kind of stuff? Yeah, go ahead, shoot.
Is key generation and accepting of the master, is that all the same?
It's all the same, yep. Exactly the same. Yeah, so when you start the proxy minion, you have to say /proxy ID. So that ends up being the node's name, and then the key generation just works from there. Because there's not really any way to ask a device, what do you want to be called? So you could, but maybe it's not what you want it to be called. Other questions? Go ahead. You can reference two different config files if you want, or you can do the configuration in Pillar, but you can just run two processes and point to two different config directories. That's kind of a wart right now we're working on. It's not really very user-friendly. We'd like to fix that. So we have a beacon. If you look in the docs, I think it's called Proxy Beacon, that can help with that. I have visions for a smart way to do that, where you just tell the master, okay, here's the host that we want to run these proxies on. You go figure it out, and then that code would just pick up the hosts and say, okay, well, I'm going to run 10 here and 10 here and 10 here and 10 here, and if they fall over, I'll start them back up. Those kinds of things. But that code's not written yet. I think that would be helpful, though. Anybody else? Okay, I don't want to run over too much. Thanks very much. I hope you enjoy the conference. And again, the code's on GitHub if you want to take a look.